Alright, in the last problem we handled parts A through D, and so we're going to focus in this video on how we can figure out where a particle changes direction. That's the subject of letter E, and also where the particle is a minimum, which is the subject of F. The two questions are closely related. It's important here to note that directional motion is indicated by velocity. By looking at the sign of velocity, we can tell what direction the particle is moving at any time t. If we differentiate s, we get the velocity function, which in terms of t is 2t minus 3. We want to know where this function changes signs. Alright, so if you think about the graph of this function, it looks like this. So it goes from negative to positive. So at this place where velocity is 0 is where the change occurs. So set velocity function equal to 0 and solve to get 3/2 seconds, and that's where the change in direction occurs. Now to answer the second question, where is the particle when s is a minimum? Look at what type of function s is. It's a quadratic, and if you graph it, you're going to get a parabola that opens up. So at the vertex of the parabola is the minimum of s, and notice that the instantaneous rate of change at that spot is 0. Okay, so the minimum is where the slope is 0. And we've already answered where the slope is 0 on question E. So it's just a question of figuring out then, for f, what s of 3/2 is equal to. So you put in 3/2 into the function that's given, and you end up with -1/4 of a meter.